Welcome to the Fundamentals of Power. For best viewing results, we recommend that you maximize your browser window now. The screen controls allow you to navigate through the e-learning experience. Using your browser controls may disrupt the normal play of the course. Click the Notes tab to read a transcript of the narration. At the completion of this course, you will be able to identify basic electricity concepts, describe electrical power and its generation, differentiate between various power usages in a data center, define power factor, recognize the importance of electrical safety measures in a data center, and identify potential problem areas in the data center. Power is a primary resource within the data center. Many instances of equipment failure, downtime, software, and data corruption are the result of power problems. Sensitive components within today's servers require power that is free of interruption or distortion. Fortunately, the consequences of large-scale power incidents are well documented. Across all business sectors, an estimated $104 billion to $164 billion per year are lost due to power disruptions, with another $15 billion to $24 billion per year in losses attributed to secondary power quality problems. It is imperative that servers are isolated from utility power failures, surges, and other potential electrical problems. The building in which a data center is located could have a mixture of power requirements: air conditioners, elevators, office equipment, desktop computers, and kitchen area microwaves and refrigerators. It is important to provide a separate, dedicated power source and power infrastructure for the data center. This course will explore the topic of power and how it is utilized within the data center. Let's begin by refreshing ourselves with definitions of some basic electrical terms. The volt is a unit of measurement of potential difference or electrical pressure between 2 points. If the 2 points are connected together, they form a circuit and current will flow. An ampere measures the amount of electrical current flowing through a circuit during a specific time interval. The ohm is the unit of measurement which describes the amount of resistance electricity encounters as it flows through a circuit. Hertz is the unit of frequency measurement. One complete cycle of change in voltage direction per second is equal to 1 hertz. Alternating current, or AC, is constantly being reversed back and forth through an electrical circuit. Power supplied to a building by a nearby utility is an example of AC power. Direct current, or DC, is electrical current that only flows in one direction. The power supplied by a battery is one example of a DC power source. To fully demonstrate how all of these terms relate to one another, let's compare the flow of electricity through a power cable to the flow of water through a garden hose. Let's use a typical garden hose as an illustration for how electricity can work. Water will flow through the hose at a slow rate or a fast rate depending on how far the faucet is opened. Water pressure, equivalent to voltage, usually remains constant whether the faucet is opened or closed. Current is controlled by the faucet position, which is equivalent to resistance. The faucet is either more open or less open at any given time. The current can also be controlled by an increase or loss of water pressure. The amount of water that moves through a hose in gallons or liters per second can be compared to the quantity of electrons that flow per second through a conductor as measured in amperes. Our garden hose analogy can also help to explain resistance. Consider a garden hose which is partially restricted by a large rock. The weight of the rock will slow the flow of water in a garden hose. We can say that the restricted garden hose has more resistance to water flow than does an unrestricted garden hose. If we want to get more water out of the hose, we would need to turn up the water pressure at the faucet. The same is true of electricity. Materials with low resistance let electricity flow easily. Materials with higher resistance require more voltage to make the electricity flow. When discussing the concept of power, it is important to understand the term electrical load. The load is the sum of the various pieces of equipment in a data center which consume and are supplied with electrical power. A typical data center load would consist of computers, networking equipment, cooling equipment, power distribution equipment, and all equipment supported by the electrical infrastructure. We will now address some of the differences between AC and DC power. As mentioned in our section on key terms, alternating current and direct current are two forms of power. Let's begin to explore the ways in which each is utilized. When the direction of current flowing in a circuit constantly reverses direction, it is known as alternating current. The electrical current coming into your home is an example of alternating current. Alternating current, which comes from the utility company, is switched back and forth approximately 60 times each second, measured as 60 Hertz. This measurement is called the frequency. The utility determines the frequency for the AC power that reaches the data center. In the U.S., frequency is set at 60 Hertz. In other countries, 50 Hertz is more common. AC power is a combination of voltage and current. AC voltage at a generating station is stepped up via high voltage transformers to voltage levels that enable power to be distributed over long distances with minimal loss of energy. Direct current has several applications in the typical data center, most commonly in telecom equipment, where banks of batteries supply power at 48 volts DC, or in battery systems supporting uninterruptible power supplies, which can be at potentials over 500 volts DC. However, whether the supply is available from banks of batteries or from DC generators, DC systems are not practical in data centers because of heavy resistive losses and the large cable sizes required to power information technology equipment. Almost all data center equipment is designed for the local nominal AC supply voltages. Now that we have discussed the forms of current, let's compare single-phase and three-phase power.